Hello everyone, blast off into the cosmos with us, Mercury, the smallest planet in our solar system, but don't let that fool you. Despite its size, Mercury holds a wealth of information and mysteries that continue to intrigue scientists and astronomers alike. This tiny world is a study in contrasts, a place of extreme temperatures and surprising secrets. From its blistering daytime heat to its freezing nighttime cold, Mercury is a planet of extremes. Zipping around the sun faster than any other planet, Mercury has fascinated humanity for centuries. Its rapid orbit, completing a circuit around the sun in just 88 Earth days, makes it a unique subject of study. Its close proximity to the sun makes it a challenging subject for observation from Earth, but that hasn't stopped us from trying to unlock its mysteries. Observing Mercury requires precise timing and advanced technology. For centuries, we observed Mercury from afar, charting its movements and making inferences. Ancient astronomers meticulously recorded its position in the sky, contributing to our early understanding of the solar system. But it wasn't until the dawn of the space age that we could truly begin to unravel its secrets. The development of space technology opened new doors for exploration. With the advent of robotic spacecraft, we could finally send our emissaries to this enigmatic world to study it up close and personal. Missions like Mariner 10 and Messenger have provided invaluable data. What we've learned so far has only deepened our fascination. Each new discovery raises more questions, driving our curiosity further. Mercury is a planet of extremes, from its scorching hot days to its frigidly cold nights. The temperature can swing from 800 degrees Fahrenheit during the day to minus 330 degrees Fahrenheit at night. It's a place where the familiar laws of physics seem to be stretched to their limits, a world that challenges our assumptions about the nature of planets. The planet's unique characteristics provide a natural laboratory for studying planetary formation and behavior. We'll explore its scorched surface, delve into its mysterious interior, and uncover the secrets that lie hidden beneath its cratered exterior. From its magnetic field to its core composition, there's much to discover. Mercury, the tiny dancer of the solar system, awaits. Its story is one of resilience and mystery, a testament to the wonders of our cosmic neighborhood. Life on Mercury would be a challenge, to say the least. Imagine a world where the sun dominates the sky, appearing 3 times larger and more than 10 times brighter than it does on Earth. Now picture yourself standing on the surface, feeling the full brunt of its unforgiving heat. During the day, temperatures on Mercury soar to a staggering 800 degrees Fahrenheit, hot enough to melt lead. But that's only half the story. Mercury's lack of a substantial atmosphere means it can't retain this heat. As the planet rotates, the surface plunges into an equally extreme night. Temperatures plummet to minus 290 degrees Fahrenheit, a swing of over 1,000 degrees, the most extreme in our solar system. This dramatic temperature variation is due to Mercury's slow rotation and lack of a substantial atmosphere. A single day-night cycle on Mercury lasts 176 Earth days, longer than its 88-day orbit around the Sun. Imagine living in a place where the sun crawls across the sky, baking the surface for months, before finally setting, only to plunge the world into an equally long, frigid night. Our first close encounter with Mercury came in the 1970s with NASA's Mariner 10 spacecraft. This mission marked a significant milestone in space exploration, as it was the first time humanity had sent a probe to study the innermost planet of our solar system up close. This plucky probe was a trailblazer, becoming the first to use the gravitational pull of one planet, Venus, to slingshot itself towards another, Mercury. This innovative technique, known as a gravity assist, allowed Mariner 10 to conserve fuel and gain the necessary speed to reach its distant target. Talk about a celestial shortcut. Mariner 10 wasn't designed to orbit Mercury but instead flew past it 3 times in 1974 and 1975, each flyby bringing it closer and closer to the planet's surface. These flybys provided scientists with multiple opportunities to gather data and images, each pass revealing more about Mercury's enigmatic nature. Despite these brief encounters, Mariner 10 revolutionized our understanding of this previously mysterious world. The data collected during these flybys was invaluable, offering the first detailed glimpse into Mercury's composition and environment. It sent back the first close-up images of Mercury's surface, revealing a heavily cratered landscape that resembled our own moon. These images were a revelation, showing a world that had been bombarded by asteroids and comets for billions of years. These images showed us a world scarred by billions of years of impacts, a testament to the violent history of our solar system. The craters and basins on Mercury's surface told a story of a planet that had endured countless collisions, each one leaving its mark. Mariner 10 also discovered that Mercury possessed a weak magnetic field, something that wasn't expected for a planet of its size. This was a surprising find as it suggested that Mercury's core was still partially molten, contrary to previous assumptions. This discovery hinted at a more complex interior than previously thought, sparking further intrigue among scientists. The presence of a magnetic field indicated that Mercury's internal structure was more dynamic and active than anyone had imagined. Although Mariner 10's mission was relatively short-lived, it provided us with a wealth of information and fundamentally changed our perception of Mercury. The mission's success demonstrated the potential of robotic space exploration and set the stage for future missions. It paved the way for future missions like Messenger to delve even deeper into the planet's secrets. Mariner 10's pioneering journey laid the groundwork for continued exploration, ensuring that Mercury's mysteries would continue to be unraveled by the next generation of space explorers. Unveiling secrets, Messenger's orbit and discoveries. Building on Mariner 10's legacy, NASA's Messenger spacecraft, short for Mercury's surface, space environment, geochemistry and ranging, provided an even more intimate look at Mercury. This mission was a monumental leap forward in our understanding of the innermost planet of our solar system. Instead of just flying by, Messenger became the first spacecraft to orbit Mercury, circling the planet for over 4 years, from 2011 to 2015. This extended mission allowed scientists to gather data over multiple Mercury years, capturing seasonal changes and long-term phenomena. Messenger's comprehensive suite of instruments allowed it to map the planet's surface in unprecedented detail, study its composition, and analyze its magnetic field. These instruments included spectrometers, magnetometers, and high-resolution cameras, each contributing to a fuller understanding of Mercury's characteristics. The data collected by Messenger painted a much clearer picture of Mercury's history and evolution, revealing a world far more dynamic than previously imagined. The spacecraft's findings challenged many pre-existing notions about the planet, offering new insights into its geological and atmospheric processes. One of Messenger's key findings was the confirmation of water ice lurking in permanently shadowed craters at Mercury's poles. This discovery was made possible by the spacecraft's neutron spectrometer and laser altimeter, which detected the reflective properties of ice. You heard that right, ice on a planet that's practically baking in the sun. Despite surface temperatures that can soar to over 800 degrees Fahrenheit, these shadowed regions remain cold enough to preserve ice. This discovery was a major surprise, suggesting that even the most hostile environments in our solar system can harbor the ingredients for life as we know it. It opened up new questions about the distribution of water in the solar system and the potential for life in unexpected places. Messenger also discovered strange hollows on the surface of Mercury, depressions that appear to be carved out by some unknown process. These features are unlike anything seen on other rocky planets, indicating unique geological activity. These hollows, along with other features observed by Messenger, suggest that Mercury is a geologically active world, even today. The planet's dynamic nature continues to intrigue scientists, prompting further questions and investigations into its mysterious processes. A heart of iron, Mercury's enigmatic core. One of the most intriguing mysteries surrounding Mercury lies deep beneath its surface, at the planet's very heart. You see, Mercury has a disproportionately large core, making up about 85% of its radius. That's like finding a peach pit the size of a grapefruit. This massive core is mostly composed of iron, far more than any other planet in our solar system. Scientists are still trying to understand how Mercury ended up with such a large core. One theory suggests that a giant impact early in the solar system's history may have stripped away much of Mercury's outer layers, leaving behind the iron-rich core. Another possibility is that Mercury formed closer to the Sun, where the intense heat vaporized much of its lighter elements, leaving behind a denser, iron-rich planet. Whatever the reason, Mercury's massive core has a profound influence on the planet's behavior, affecting its magnetic field, rotation, and even its interaction with the solar wind. This unusual core is a key piece of the puzzle in understanding Mercury's formation and evolution, and it's a mystery that scientists are eager to solve. Thank you for watching. Don't forget to hit the like button and subscribe for more fascinating content.